Okay. Hello, everybody, and welcome back to the Azure podcast. Today is December 5th. And ironically, after going a couple weeks without any shows, we've not done three in 3 days. We probably won't publish them in 3 days simultaneously, but if everybody sees us repeating the same dates. This is episode number 510, and we're going to be talking about and I want to get this right because there's an intent here after we'll talk about, but Azure Kubernetes Fleet Manager. Our special guest will sort of explain why that was important in a couple of minutes. We don't have any news because we've had a couple of shows this week. I'm joined by my fellow co-hosts Cynthia and Kale, and then Stephane Erbrech is here from the Fleet engineering team. So, Stephane, go ahead and introduce yourself because I said we don't have any news this week. So we go straight to you. Who are you and what do you do here at Microsoft? We'll start
hi everyone. I'm Stephane. I'm working in Azure AKS team, and more specifically on Kubernetes Fleet Manager. I'm an engineering manager there, and one of the tech lead who has brought Fleet Manager to life. That's okay. My role.
Great. Yeah, and so you actually mentioned it, and because you said the word, so I'll ask the question. You live within the Azure Kubernetes Service sort of world, but this is Kubernetes Fleet Manager. Why the distinction?
Well, the distinction because there's more than just AKS to Kubernetes, even in Azure. Azure has the concept of other types of Kubernetes clusters that you can connect via Arc, for example. And the end goal for Fleet Manager is to be a fleet manager for those as well, not just AKS. We do have in mind the customers who want to run Kubernetes on the edge and who wants to maybe also to be multi-cloud and all those other types of workload. So effectively, currently, Fleet Manager, the service, is still very focused on the main target, which is AKS, or the core target, and then the low-hanging fruits. But the end goal is to expand and have a fleet manager that take care of much more than just AKS. Yeah.
Okay. Cool. Well, yeah. So we sort of jumped ahead a little bit, but maybe start with what is this fleet manager thing? Why do I need a fleet manager beyond all these different clouds and all these different clusters that I have? But how does Fleet Manager help me with that?
So it's a topic that grows also in the Kubernetes community as a whole, and as Kubernetes has become a more and more popular way to host services for the companies that runs on the cloud or on premise. The question starts. So where we had the problem before of I have more and more VMs and I need something to manage them, and we landed on an orchestrator that abstracts those VMs. Now the same customers who have grown the use of Kubernetes end up with so many Kubernetes clusters that they need something
same problem
to abstract them. And so we have more and more customers who end up with 10 or hundreds or even sometimes thousands of Kubernetes clusters in the organization, and start to really struggle to manage the life cycle of these clusters, to the compliance of these clusters, keep them secure, also manage the deployment to these clusters. When you want to distribute your application across hundreds of clusters, how do you deal with this at scale? And that's where Kubernetes Fleet Manager comes into play.
Okay, makes sense. So help me. I'm not. I understand Kubernetes, sort of in a general sense. But I thought the whole point of Kubernetes was to abstract that infrastructure from underneath you. But I think we were talking to somebody from the functions team yesterday, and they were talking about the fact that even if you love the functions runtime, at some point it has to run somewhere. Is that sort of the same problem here? Is the app developers may not really care about the clusters, but somebody owns all these clusters, and Kubernetes moves really fast too, right? You could be 2 versions out and you're out of support, at that point. So it's a pretty fast treadmill.
Yeah, so Kubernetes gives you lots of abstractions over concepts that you eventually need when you run many apps and microservices, as people like to call them, in your environment, like load balancing and orchestrating and automatic scaling, and so on. But those concepts are still built on top of networking concepts, and you still have all this complexity of managing the infrastructure. And when things fail, you still need to understand what failed and be able to troubleshoot it and all. So, so Kubernetes is still an investment. Most organizations who run many Kubernetes clusters end up having an entire team dedicated to managing those clusters. And the cloud services like AKS try to limit and reduce more and more the amount of work that those teams have to do to run those clusters, to keep them safe and up to date, and monitor them and so on. So there's a spectrum there of how, from the user who just wants to run his app, and Kubernetes is the most, like, the easiest way to go for them because of some reason. And so AKS then has some solution with AKS Automatic that came up to simplify all those choices. But then you have the customers who have the need to run massive workload at scale, and they need the little knobs and control, and then they also need to manage all these Kubernetes clusters at scale, with all the pain that comes with it. So yeah, there's always a lot to monitor, care about, understand about highly available services, disaster recovery. All those aspects don't go away. They move. They get handled in some ways by the cloud services and the facilities that comes with them, but they're still there, and so you still need that team who cares about the infrastructure.
Somebody has to in the end,
exactly.
Right? Like it's not completely abstracted.
Yeah, one question I had was, so let's say you had a bunch of AKS clusters, for instance. Do they have something that gets deployed on them? Like, how does this work? Like, how do they know? Do they even know they're part of a fleet themselves, like the actual AKS cluster? Or like,
A good question. So we try to make it as transparent as possible from the cluster's point of view, but we do provide the facility. So Fleet Manager is here because, so first to manage the lifecycle of the cluster, but also to manage the workload that we deploy on them. So once you want, like, it's very, very similar to how Kubernetes decides to deploy your applications on this or that node. Now, when you have many clusters, you need to have a facility to decide to deploy the application to this or that cluster. That might be because you want to be distributed in different regions, and you need the same application to be deployed across many regions for latency purposes, maybe for availability purposes. Or it might be because you have a fleet of clusters with lots of compute capacity, and you just want to run it where it's the cheapest. And so the scheduler from Fleet is able then to pick the cheapest compute for your workload, or figure out maybe there is capacity differences, and you can have GPUs in one region and not in the other one. And so you just want to deploy your app wherever there is GPU. So you'd give it to Fleet Manager and figure out which cluster has capacity for the GPU workload you have. And so it just abstracts, it tries to abstract the Kubernetes clusters and what's available there from how you deploy your application, and also reduces the complexity of, if you have GitOps, if you work with GitOps and you want to deploy, you use declarative deployment, so that your deployment is based on what you have in a Git repository. It ends up on your cluster on as a deployment. And if you have 100 cluster, then that GitOps infrastructure and configuration becomes very big and complex, because you suddenly need to pick and choose which cluster you want it on. And Fleet Manager gives you an extra abstraction where you can do GitOps then against the Fleet Manager, and Fleet Manager takes care then of the placement of those workloads across the cluster. So you reduce the complexity that you have to manage in your GitOps infrastructure, in your GitOps configuration, and Fleet Manager then takes care of the deployment itself. So yeah, so to answer your question was that you still have to manage the workload. Yes, absolutely. Fleet Manager gives you just a unified control plane to deploy the workload across your fleet, instead of having 100 Kubernetes control plane to deploy to, you just have one.
Okay, kind of following up on that point, could a single cluster belong to multiple fleets, or is a cluster to fleet relationship a always one-to-one?
Very good question. It is always one-to-one. So we ensure that a cluster can only be part of one fleet. So there is multiple reasons for that. One is just simplicity, but the other is if you have multiple fleet controlling one cluster, then
the overriding of like which one takes precedence.
How do you make sure which one takes precedence? Exactly. That we for the deployments, but there are other aspects to fleet like that customer appreciate quite a bit already, and it's the management of the life cycle of your clusters. So Kubernetes, in Kubernetes, you have a fast-paced version upgrades with patches, and so often security patches generate a patch in Kubernetes in all the minor version. Then every minor version comes out every 6 months, I think, and there's quite a fast pace of upgrade that a customer has to follow to stay up to date, secure, supported on Azure. And so when you have one cluster, it's easy to enable auto upgrade. But when you have 100 and you enable auto upgrade on all of them, suddenly clusters get upgraded at different time, different pace. And you do want to control that first the development cluster gets upgraded, then the staging cluster gets upgraded, and you verify that this works for your application. And only then do you move to prod. And even when you move to prod, you still want to reduce the blast radius of a potential issue. So you want to move slowly. And Fleet Manager allows you to configure all that across your many clusters so that you perform those upgrades at the pace that works for your organization. That's valid for the resource upgrades, but also for the workload deployment that we talked about just before.
And quick follow-up on that.
Go ahead, Cynthia.
Is the boundary of a fleet usually a single workload, or like how do we visualize what should belong in a fleet versus setting up a new fleet?
Yeah, that's another very good question that has come up several times, and we more or less leave it so we provide the means to create fleets and group the clusters the way you want. So the way we've built Fleet currently is we favor a way where you would have one fleet to control all your clusters, and you would group the clusters then in, for example, those are the dev clusters, those are the staging clusters, and those are the prod cluster. And by doing this, you then are able to stage the deployments, both of your applications and of the upgrades of the clusters themselves, to flow through those different groups. It's a perfectly valid solution as well to decide to create a few different fleets to completely isolate development from staging from prod. But then it's up to you then to manage the orchestration of the deployment that goes first in development, then in staging, and then in prod. Because currently our scope of the fleet, like our scope for the upgrade and controlling the orchestration is the fleet. And so we don't have, at this time at least, we don't have a way to orchestrate across fleet. That might come in the future because you
have so many fleets, you need a fleet manager to have
exactly right.
I can see it coming.
but in the end, it's a valid use case where some customers prefer to completely isolate the environment between, like to completely block and isolate the environments at the resource level, at the Azure tenant level even, and then you can't put the different resources in the same fleet. And I think in most cases, then the orchestration between the two is manageable, but maybe we'll have to provide in a way to link to a fleet to provide that orchestration, but we're not there yet.
It is. I think you had me for a little bit. We were talking about the infrastructure and managing the versions and all that, and then you mentioned as an app developer or an app owner, I'm gonna sort of pick which fleet I'm gonna deploy to. Is the target audience really both audiences, both the app owners who have to go deploy it and they don't really care much about underneath it, as well as the infrastructure folks who actually own these clusters? Like you sort of. I thought at one point we were just talking infrastructure, but it sounds like there's a little bit of an element of, as an app owner, I gotta pick something to deploy. Okay, so there is a sort of a dual piece to this then.
So there is absolutely two different aspects to Fleet. One is the resource management, much more targeted towards the ops team who needs to manage the amount of resources they have on Azure and the security of those deployments. The other side is the application owners and the different team who develop application and deploy them on top of those clusters. Here, there's still the choice is still there. They still have access to their individual clusters. So you can very well use Fleet just to manage the resources. And in that case, it's even so there's two modes in Fleet. You can have Fleets that only manage the resources. And then the deployment is very simple, and currently it's even free, up to 100 clusters that joins the fleet. And then there's another mode where you enable what we call a hub, and that hub is an API server, a Kubernetes cluster with an API server that allows them to deploy application onto all the members. But you can decide to not enable this and only manage the resources. And even if you do enable it, the API server of every cluster is still there. So you can keep the exact same process, the exact same deployment patterns that you have today, and start managing your resources. And then you can start moving some maybe infrastructure-related deployments at the fleet level to ensure, for example, that some policies or some type of guardrails are deployed on every cluster in your fleet. Maybe you want something like a security deployment, like things like that we see like Kyverno or things like this that runs on AKS or on Kubernetes cluster to ensure it's secure. Maybe the infrastructure team wants to ensure that every cluster member of the fleet is running that payload. And then Fleet is a great way to ensure that, because you configure the deployment at the fleet level. And you say that this deployment needs to be in every cluster in the fleet, meaning that when a member joins, a new cluster joins the fleet,
it gets pushed there as well.
It will get pushed there automatically by the fleet, because you can write policies that every cluster in the fleet has that deployment.
Yeah, along with that, I was wondering about like the security model here, because like at least in some enterprises I've seen where people will say, hey, there's Kubernetes clusters, and it's like an administrative like security boundary kind of thing, saying here's this cluster and here's this other one. Now, if they join a fleet because let's say they're getting updates or something like that, is there like a lot of granularity there with the security to be able to say like, hey, don't touch my cluster except for you can do my updates and stuff like that, and then we'll manage the rest of it, kind of thing?
So let's see. The way this works today is that you still have the API server of each cluster and the access to the API server is controlled by Azure Erbrech. That's AKS world, right? And Azure world. So Azure Erbrech controls that, and that stays in place. Now, Fleet has the exact same concepts of Erbrech, and so you have Fleet roles that are matching the AKS roles to be able to get to be allowed to configure things on the fleet. So only fleet administrator should be able to deploy things, or a specific role should be able to deploy things on the fleet. So at this level, you have the control and can decide who can do what at a fleet level, which is a very privileged role, effectively, because you have access to deploy anything to any cluster if you configure it this way. So those controls are there. There are more things that we're working on to enable, for example, specific development areas, development namespaces, and anything that is valuable at the cluster level will eventually have an integration at the fleet level, because if you start managing a fleet of clusters, then and you want, for example, to manage add-ons or policies or upgrades, as we discussed before, if you buy into Fleet, then Fleet is there to manage all this for you at the fleet level, and so we'll move more and more integrations at that level when it makes sense. Including things like federated identities that we're looking into, or those are things that we don't necessarily have an ETA, but it's clearly things on the roadmap because it's obvious we need a solution for them.
So this makes a lot of sense, and as I sort of look out there, I can think of, I mean, at least a half a dozen internal teams in Microsoft that have just a few clusters underneath the services that they're running. Are we using, and maybe it's not exactly what we're shipping publicly, but are we using some variant internally, or maybe that's where this started?
So there was clearly, as the usage of Kubernetes grew within Microsoft,
Right.
and the usage of AKS grew within Microsoft, there were more, like, some efforts started to think about Fleet, and at the same time we had customers in AKS telling us, hey, I have that many clusters, same problem. So we started building Fleet. Now the focus of Fleet Manager and the focus of AKS has always been to always look at our external users and satisfy the external users before trying to satisfy the internal users, because I think like George Palma from AKS would talk much better about this than me, but by satisfying all the external users first, we eventually satisfy all the needs of the internal users, but in a way that is more approachable by the external users. And there are other examples previously that have started more as an internal effort, and when they try to make it available to the external users, it failed because the complexity is very different and the needs are quite different too.
Yeah, I'm because I come out of, before I moved to or back to the support role that I'm in now, I was in the customer reliability team, and we as part of the platform reliability conversation, there's a lot of conversations around, how do we make sure that we're consuming internally what our customers are consuming, right, and all that. And again, totally fair that you're not there today, but like I see it on the roadmap, like I see it. I'm sure there are some conversations,
absolutely,
because it just makes our platform better, right? When we're using the same thing our customers are, like, it just makes life better for everybody in the end. So
this is already happening. We have many discussions with internal teams who desperately need something like Fleet, and we take all the input from these internal teams, and we take the inputs from the third-party customers, and we organize how we can organize that roadmap and prioritize the things to eventually meet both at the end of the tunnel there. And it's slowly happening, and Fleet has as we keep building, the value proposition from Fleet becomes impossible to ignore from both external users and internal users. So we're getting there.
Yeah, absolutely. Great. Well, no, this is awesome. I really appreciate you coming to talk about this. I know you were a little bit nervous coming in, but great. Anything last, sort of any major things we missed that you want to highlight for the audience?
Yes, actually, there's one thing is that so Fleet is a service. Fleet Manager is a service on Azure, but the guts of Fleet is an open source project. It's on GitHub, GitHub/Azure/Fleet.
We'll have to get the link. Currently. We'll share the link. In the show notes.
And everything that powers Fleet in the service is exactly what's in there. And so someone who might want to run a Fleet and appreciates the feature set that Azure Fleet Manager provides can install this on their Kubernetes cluster locally, or even in any other cloud, and it will just work. It will work the same as what we do in Azure. And the goal for this is because we want to expand this to to be able to manage multi-cloud solutions, to be able to manage edge clusters, on-premises clusters, and so on. And that project is in the process of being submitted to the CNCF.
So I got to ask the follow-up question that then if I can go deploy this myself, I mean, obviously there's the obvious benefit of like y'all are managing it for me, and I'll pay a little bit of a premium for that because then I don't have to manage it. But is that sort of the way y'all are looking at this as a service? Is you're sort of making sure it runs well and it runs best, and I don't have to manage Fleet itself. I just manage my clusters. But okay,
that's correct. That plus many bells and things that we add on top at the service layer, not as the core functionality, but as the integrations that we can make. As in UI things in the portal, monitoring aspects that or one-click configurations, or the entire part that is about upgrading the cluster is a service-only solution. Because at that point, it's to orchestrate the upgrade of resources in Azure, linked to other systems in Azure. So all that aspect is really Azure service only. The part that is open source is the data plane that we talked about, which is more than deploying the applications and managing the scheduling of them.
Okay, that makes sense. So it's sort of there's a word for it that I can't remember. It's sort of a both model, right? There's some core piece that is open source, and then there's the rest that we're deploying. Okay, great. Well, no, that's awesome. Really appreciate you coming on to talk about it. You know, I'm not enough of a Kubernetes guy to probably be using it, but I suspect lots of our customers are, because you're right. Lots of people have lots of clusters these days. It's crazy how big some of these get. Great, awesome. Thank you very much. Appreciate it.
Well, thank you for having me, and maybe I'll be back after we have functionality to talk about.
Absolutely,
talk about the new stuff coming.
Absolutely, I'll put a note on my calendar for 6 months, and we'll have you back on. George has been on in the past talking about. I can't remember what he talked about. So we've had the broader team on. We'll have you back for sure. Thanks, appreciate it. Bye.
Thank you very much, guys. Bye.